Hello again, everybody. This is the Crazy Canuck coming at you from Saskatchewan, Canada. If you remember, the first video I did was on Brix and the explanation of how that relates to growing nutrient-dense food. This video is going to be the practical application. Now, we're going to start off with the Brix chart, which shows a lot of your fruits and vegetables and a general idea of where the Brix levels should be for poor, average, good, and excellent. Now, the Brix readings themselves can actually be lower or higher than what's on the chart, but this will give you a general idea. Now we'll just go and check some stuff. Alright, so we're going to check some fruits and vegetables, check the Brix, give you a practical application for this technology. So I went to the store and I got 3 different apples. 3 different brands. I got an onion out of the garden that I grew on soil that was solid clay 3 or 4 years ago, and I've made a garden out of it. A Egyptian walking onion that I grew in the greenhouse, and some store-bought onions. Now there's going to be some interesting sidebar to this one, and we'll go through it as it happens. So what I'm going to do is I'm first going to cut all 3 of these apples. Now we're going to take 1/2, line them up, and then we're going to check the Brix on them. So how you do that, the easiest way, you take a small sample, you take a garlic press, like you probably press it with your hands, but you can take a garlic press, you take your refractometer, oop, yeah, it's just pouring juice out there, you put a couple drops on your refractometer, and then you hold it up to the light and get a reading. Now hopefully I can do this on the camera. Maybe. Sort of. You can see right there, it's where the blue, it's not wanting to focus. Isn't that nice? Where the blue and the white meet, that is your level. Now, just looking at it, that apple is 13 Brix. So we'll just write that down here, 13 Brix on this one. Then we'll clean out the sample out of the garlic press and move on to the next one. Our next sample is going to be this one. And between, it's always a good idea to clean off the refractometer so you don't get cross-contamination. And you do the same thing. You can just squeeze the apple, get a couple drops on there, hold it up to the light. Let's see if this will work any better. Got to get it right one of these times. And that one looks like it's going to be about 14 Brix. So we'll put 14 down. So far these aren't very good. I'll just check the chart. The chart says that 14 is good, but it's definitely not excellent. So now we'll do the same thing with the third one. Third apple. Same thing, take a piece of the apple, stick it in the garlic press, get a couple drops on there, hold it up to the light, and if you can see that, that is about 13 bricks. Now what I've noticed on these is there is a fairly distinguishable line between the blue and the white. Now what that means is that there isn't a lot of mineralization happening. The more mineral you have, the fuzzier that line's going to be. So now we've got our 3 apples that are generally around the same bricks, which really won't help us in a secondary experiment on browning. I've done this before where there's a substantial difference in the apples, and the time it takes to brown is directly related to the Brix levels. The higher the Brix, the slower they brown. So when they want to genetically modify an apple so that it doesn't brown, they could get the same result by actually growing healthy fruit. So let's check some onions. Let's start with the store-bought. Same thing, put it in the little garlic press. Make sure the refractometer is nice and clean. Helps we get enough in there to actually get some juice out of it. And we'll check that. And as you can see, we're sitting, if I can get that lined up again, at around 9. Now, for all intents and purposes, food, in my opinion, starts at 10. When the sugars are at that level, then the plants are a lot healthier. They start to develop sugars, or take the sugars to develop proteins, that kind of thing. So that's our store-bought onion. That's sitting at 9. Now let's check the Spanish onion that I grew in the garden on not the best soil. So we'll just get a chunk of that. Get a drop on the old refractometer. And you can see that one is around that 13 mark. So already we're much better, even with poor soil, than what the store-bought onions are. Now let's check what happened with the Egyptian walking onion, which is a nice heirloom that I grew in the greenhouse. Same thing, put a few drops on the old refractometer here. And as you can see, we are sitting, if it'll show, around 23. So 23 bricks on the heirloom, old variety, lack of technology onion. So let's take a look at the chart, see if we can find onions. They say 10 is excellent. I would say 10 is where you should be starting. So as you can see, what you grow yourself can be a lot better than what's in the store. Now we're going to go and check the old grow center that I showed on a previous video and do some testing for my light experiment. Okay, here's our grow chamber. I'll give you just a quick scan of what's happening here. Did some transplanting, but like I said, it's going to be a little while before everything kind of takes off. Looks like some of the fava beans really doing well. So now if you can tell a difference, this set of fava beans is under my shop lights. And if you come back over here, This set of fava beans is under the T5 high output grow lights, fluorescent. Now there's definitely a color change, definitely a difference in color. So what I am expecting is that the shop lights are going to fail this test, and I'll be able to replace them with the LED grow lights from Hidden Harvest grow lights for the next stage of this experiment. I have 2 on order, and I'm hoping to have those in my hands in the next couple weeks. So let's get this all set up and we'll do some Brix testing. So first I'm going to sacrifice the fava bean on the side of the T5 high outputs. When Brix testing, it's always good practice to take from the growing part of the plant, which in this case is in vegetative growth, so you want to take the vegetation. If it was actually in reproduction and making pods, you would take from the pods. Just pulled one up here, you can see a fairly nice root system. So we'll get that in there, see if we can get some juice out of this thing. Sometimes it can be a challenge to get a little bit of juice. Get it on there. Hold it up to the light. And that one looks like it's going to be about 9 Brix. I'm not sure if you'll be able to see that on the camera or not, but that one is 9 Brix. Now we'll take a sample from the other side under the LED shop lights. Clean. Give her a little squeeze. Nice little sample on there. And those ones are sitting at about 8 Brix. So there is definitely a little bit of a difference between the two on the basis of being completely on the light spectrum of the T5s and the LEDs. So there's 1 Brix difference. So now we're going to check the center of the grow area, which would have a little bit of overlap between the two, and see how much of a difference there is. We'll first take from the T5 side, much larger plant. Make sure we start off with a clean refractometer. Get a little bit of juice, which is a lot easier out of that one. And checking it. Interestingly enough, that one's only 6 Brix. So definitely a bigger plant, but there's a lot less value in it. And that's on the side of the T5s. So now we're going to clean that out, and we're going to go for the other side under the LED shop lights. Taking where the plant is putting all the energy, the end of the plant. Cleaning off the refractometer. Getting a small sample on there. And that one is just around 5 Brix if it shows that. So the big lights, there isn't a whole lot of difference in the Brix on fava beans. It'll be a little while before we can Brix test anything else in here. But so far, no real clear winner between the two. Stay tuned for another update, probably in a week or two on this topic. And we can do one more thing while we're here. And that's to check the electrical conductivity of the soil. So this is my EC probe. It's about a $400 unit. You don't need one this expensive. I do a lot of field crop checking in the summertime, so I just opted to have one that was a little bit more expensive. So all you have to do is stick it into the soil, and it's going to give you a reading. Now this is soil is from my containers in the greenhouse, and there's also a lot of red wigglers in here. So I would expect a high number from biological energy. Now I'll see if I can get this camera over here. I'll show you. So the number that I'm getting, I've got about 700 in this spot. Let's check over in the root zone of the fava bean. Notice it, substantial increase. Like that's 1100, almost 1200 around the root zone of the fava bean. Let's check this other fava bean root zone. Get 1300, 1100. We'll check over here. We've got 900, almost 1000. Let's check over on this other side here. 1200. Now we can check in a random spot in the bed. And we get 2300. That's a good spot when you're talking biological energy. If this was salt-driven energy, there would be nothing that would grow in this soil because it is just too hot. But because we have a lot of biology going on here, that's where your energy is coming from for this soil. So we have the energy, we just have to get that energy to the plant, which is not happening under these lights. So we're going to give it another probably couple weeks and come back and take some more readings, and then I'm going to be setting up the Hidden Harvest grow lights, and a couple weeks after that we're going to be doing some more testing. So that's all there is for now on the light test. So far it doesn't seem to make a whole lot of difference between growing with the T5 high outputs and the shop LEDs. Now, interestingly enough, the T5 high outputs, I have 4 of them in here. I'm not sure if I'll be able to show. 4 T5s, over 50 watts a piece. So there's 200 watts on this side. And these are the shop lights that I got, these LEDs. 4 of them, about 34 watts a piece. So you're looking at a huge wattage difference going from 200 to, whatever these other ones are, 100 and whatever. And so if we're getting the same results, the only takeaway from this test so far is that the LEDs will cost you less to run the same system as the T5 and have very similar results. So that's the test for now, and we're going to go back and check out those apples and see what's going on there. So here we are back at the apples, and as expected, there isn't a lot of difference between them. They were all within 1 Brix of each other, so you know, not a very good scientific way of doing any kind of a trial, but that's what you get when you're buying. But the real solution here, depending if you're not fussy about what type of apple you get, this is the way you can go into a store, buy 1 apple, you can go out of the store, check the Brix on it. If the Brix is high enough, you go back and buy more. If it's not, then you can try another brand. I always Brix test my crops every few days to a week in the field, and it's a good way to see how they're producing sugars and growing. Another interesting little side note, in the grow beds, in the grow chamber, I had planted fava beans in flax, and in that situation the fava beans actually increased the soil energy by 100 points. In the situation we have in the soil, because it's so biologically rich, what the fava beans have done is actually used that energy for growing, and the areas that I checked that didn't have a lot of plants growing yet had higher energy because there's more biology, more energy that hasn't been used by the plant. So that's probably about it for this video. And I see it's another lovely snowy day out there. This is the reason you have to grow inside. So that's it for this video, and look forward to more as time progresses and we do more testing and come up with more videos and more ideas. So that's it. Subscribe if you haven't, and like if you like, and we'll talk to you later. So long for now from the Crazy Canuck.